Well, now, welcome back. So we're looking at family of curves, and we're looking at example number 3 and number 4. It's going to have the roots of 5 plus or minus root 13 over 6. Well, we didn't come up with that answer by factoring, did we? Take a look at the roots. Did that come up by factoring? Was there a quadratic that I was able to do this, where I know what B and C are from this? No way. It didn't come from factoring. Where did it come from? It came from the quadratic formula. That's where that came from. That's where those roots came from. So they came from me looking at minus b plus or minus square root b squared minus 4ac over top of 2a. It came from that. And it kind of looks like that still, doesn't it? Look at this. You've got 5 plus or minus 13 over 6. Now, math is all about patterns. Let's compare these two. Let's see if we can see anything that sort of matches up. I kind of see something. I don't know about you guys, but I'm seeing a negative b is sitting here with the 5. Do you agree? I'm assuming all of you are sitting there going, yeah, we agree. So I'm thinking that negative b equals 5, so b equals negative 5. I think that's my first information that I've pulled out for this. What do you think? I'm going to ask the person that's sitting here. What do you think? Yeah? Okay, so what's the next thing that I'm sort of going to compare? The next easiest one, I think, is this one. 2a must equal 6. They're in the same spot, right? So that means that a must equal 3. Okay, so I got b, I've got a. And the last one to compare, really, is what we call the discriminant. And so you've got b squared minus 4ac equals 13. Well, I know what b is. It's negative 5. So I can do negative 5 squared. I know what a is. It's 3. I don't know what c is. But I have an equation here that I can solve. So I'm going to get 25 minus 12c equals 13. I'm going to take the 25 over to the other side. So I get negative 12c equals 13 minus 25. And I think that's 12, isn't it? Negative 12? So I'm going to divide both sides by negative 12, and I'm going to get c equals 1. Hey! I know what a, b, and c are. So the quadratic used to look like this. Well, it didn't used to look like. It does look like. That's the family of curves that came from a quadratic formula, right? The d allows it to get larger and smaller and all those good things. This is what I'm going to be able to plug in. So if I plug in my a value, and if I plug in my b value, and if I plug in my c value, my family of curves will be 3a squared, not a squared, sorry, x squared, minus 5x plus 1. And I'm going to ask the person sitting here if that makes sense. Okay? So that is all of the quadratics that have these roots. Okay? 5 plus or minus root 13 over 6. Allowing for them to be larger and skinnier and fatter and shorter and all of those things with the d value. Now the question goes on a little bit. The question's asking me to find the exact equation. So the exact guy is going to pass through this point. Probably shouldn't use red. I've used red already, but there you go. So I'm going to plug in my x value here, and I'm going to plug in my y value here. So that's going to give me 15 equals d, and it's going to be 3 times 2 squared minus 5 times 2 plus 1. So it's going to be 15 equals d. Now the 2 squared is 4 times 3 is 12 minus 10 plus 1. So I think that's going to be 3. So I've got 15 equals d times 3. Divide both sides by 3. I get d equals 5. So I'm going to take that and plug it into my family of curves. And that's going to mean, so I take this and plug it in here, I'm going to get y equals 5, 3x squared minus 5x plus 1. And finally, that could be 15x squared minus 25x plus 5. and that is your specific curve. So this one was a little bit different. We had to take a look at the roots and realize that it came from the quadratic equation, use the quadratic equation to compare the values, came up with my family of curves. Now remember, I can't put this family of curves in factored form. It doesn't factor, remember? That's why we use the quadratic formula. So it's going to have to be put in expanded form. Now this is certainly expanded form. This is more expanded, and we would call this in standard form because it's ax squared plus bx plus c. So this is what we're going to call standard form when it's fully expanded. Okay, I have one more to do. I'm going to stop the video and we'll do the last one.